Hey everyone, welcome to this explainer. Today, we're taking a completely mind-blowing journey through the evolution of computer networking. We're going to trace the invisible threads that literally connect our entire world, starting from a single, clunky remote calculator all the way to the sprawling wireless globe we live in today. It's an epic story of engineering, and I am so excited to share it with you.
Okay, let's jump right in. To really anchor ourselves, check out this absolute night and day contrast. On one side, we have the earliest days of remote computing in the 1940s, which eventually led to early modems just kind of chugging along at about 110 bits per second. And on the other side, we've got modern Ethernet and Wi-Fi networks capable of blistering speeds up to 800 gigabits per second. I mean, just look at the sheer scale of that number, 800 billion bits per second. Seeing all those zeros written out really shows just how far our connectivity has evolved in roughly 80 years. It's a leap in capacity that has completely transformed how human beings interact, work, and share knowledge.
So here is our roadmap for today's explainer. We'll start with the very first remote connection, uncover the military roots of ARPANET, check out hardware heroes like modems and routers, trace the birth of Ethernet and the internet, and finally, unpack the wireless revolution.
All right, part one, the first remote connection, 1940 computing.
So let's look at how this all started. Long before we were, streaming 4K video on our phones, a guy named George Stibitz fundamentally changed computing. In 1940, he connected a teletype terminal at Dartmouth College in New Hampshire to a complex number calculator all the way down at Bell Labs in New York. He successfully sent data across state lines, proving for the very first time that computers could actually be used at a long distance. This single event laid the earliest conceptual foundation for the networking we rely on today.
Moving right along to section 2, military to ARPANET, and those Cold War origins.
Fast forward a bit to the Cold War era. What's wild here is just how fast these stepping stones happened. In the late 1950s, the US military built a massive computer network for the SAGE radar system to monitor airspace. That military necessity spurred a massive drive for robust, decentralized communication systems, which led directly to the invention of packet switching in the 1960s, the launch of ARPANET in 1969, and eventually the invention of Ethernet in 1973. We absolutely have to talk about packet switching, because it's literally the bedrock of all modern networking. During the 1960s, Paul Baran and Donald Davies independently invented this concept. They realized that sending continuous, unbroken streams of data was super risky. If a line gets cut, the whole message fails. Instead, they designed a system that breaks data into small blocks, or packets. Actually, think of it more like a survival tactic. It was designed for network survivability in hostile environments. If one path failed, the packets could simply take another route and reassemble at the destination. Pretty brilliant, right?
So, that highly survivable architecture gets put to the ultimate test in 1969 with the ARPANET. This was a truly historic moment. The network's very first 4 nodes connected UCLA, the Stanford Research Institute, UC Santa Barbara, and the University of Utah. Now, they communicated over circuits running at 50 kilobits per second. While that sounds agonizingly slow to us now, it was the direct, undeniable precursor to the global internet.
Which brings us to section 3, modems and routers, the hardware heroes. We really can't talk about all this networking history without giving a shout out to the physical hardware that made all this theory a reality. First up is the modem, short for modulator-demodulator. The first commercial modem for computers, the Bell 101, was actually released in 1958 for that SAGE system we mentioned earlier. It cleverly allowed digital computers to talk over standard analog voice telephone lines. It modulated digital signals into analog audio tones for transmission and then demodulated them back into digital data at the other end. But, as these networks started getting bigger than just simple point-to-point connections, we desperately needed a traffic cop. And that's your router. A router is an essential device that forwards your packets between different networks. Instead of inefficiently shouting every piece of data to every single computer on the network, a router processes routing information and IP addresses to send your data exactly where it needs to go, dropping it off at the next correct stop. I love this because it perfectly illustrates the whole concept using something we all know, the Postal Service. An IP address functions exactly like a street address on a physical envelope. When your computer sends a request, your local router, and then your internet service provider's routers look at the destination IP address. Just like postal workers sorting mail, they use their internal routing tables to pass the packet closer and closer to its final destination, all without needing to know the entire route from start to finish. All right, on to section 4, Ethernet and the internet, establishing those global standards. So let's dive into the 1970s. This is the decade where these kind of isolated military and academic systems finally merged into a public global standard. In 1974, Vint Cerf and Bob Kahn published a seminal paper on internetworking, which simply means connecting multiple different types of networks together. Later that year, they wrote the first Transmission Control Protocol, or TCP, specification. This is a massive milestone, guys, because this is exactly where they coined the term internet as a shorthand for internetworking.
Now, while the internet was figuring out how global networks talk to each other, we still needed a highly efficient way to connect local machines in an office or on a campus. Enter Ethernet. Step 1. In 1973, Robert Metcalfe wrote a memo at Xerox PARC outlining a local area networking system. Step 2. By 1980, Ethernet was standardized, running at a swift 10 megabits per second. Step 3. Fast forward to today, and that exact same foundational technology has scaled up to a mind-boggling 800 gigabits per second over optical fibers. Its incredible ability to scale is exactly why we still use it heavily today. And finally, Section 5, the wireless network revolution. Let's bring this explainer back to the present moment and look at the invisible magic you are very likely using to watch this right now, Wi-Fi. What we commonly call Wi-Fi is essentially a wireless local area network based on IEEE 802.11 standards. Instead of copper cables or glass fibers, Wi-Fi acts as a bridge, using high-frequency radio waves to transmit data between your client devices and the access point. It feels like absolute magic, but it is deeply rooted in the physical science of radio transmission, which, of course, comes with its own unique set of challenges. Now, there's a fascinating limitation to this technology that a lot of folks actually don't know about. Wi-Fi is a half-duplex medium. That means only one device can transmit on a given frequency channel at a time. Your devices must constantly take turns talking and listening. If they try to talk at the exact same time, boom, their radio waves disrupt each other. This is exactly why a crowded Wi-Fi network with tons of devices suddenly slows to a crawl. They are literally all waiting in line to speak. And because it all relies on radio waves, Wi-Fi is completely at the mercy of your physical environment. Radio waves are disturbed by electromagnetic fields. They are effectively blocked by dense materials like concrete walls and steel doors. They bounce around rooms, creating standing waves or localized dead zones. Heck, they can even be interfered with by your microwave oven or a Bluetooth speaker. Building a perfect wireless home network is incredibly complex. Which brings us to a huge, incredibly practical takeaway, what I like to call the golden rule of networking. Despite our amazing wireless revolution, if you want the absolute best speed and reliability, connect your most important stationary devices with a physical network cable. A hardwired Ethernet connection completely bypasses all the unpredictability of the open air. It remains the undisputed champion for speed and stability, for sure. Wow. Okay, we've covered a massive amount of ground today tracing this history. Think about it. If we went from a single remote calculator connected by a clunky teletype to a wirelessly connected globe in just 80 years, what in the world will the network look like tomorrow? Are we going to be relying on nanoscale networks, or maybe an interplanetary internet connecting Earth to Mars? It's a fascinating thought, and it just proves that the evolution of networking is far, far from over. Thank you so much for joining me for this explainer, and keep learning.